how do you? You've got a lot of that weight now is back in behind the passenger cabin. I assume your center of gravity is probably somewhere, given that weight, right around the middle part of the cabin. Is it?
Correct, but not in the cabin.
Okay.
In the wing strakes.
Okay.
The aircraft was designed around to be a long range 1,400-mile aircraft on gasoline. So there are two very large liquid fuel tanks originally designed into the wing strakes.
Okay.
And plus a 23-gallon reserve belly tank, which we use to feed the range extender generator.
Right.
But the fuel tanks in the wing strakes and outbound in the wings in compartments is where we've integrated the ESS, the battery packs.
Okay, so let's talk about a little bit about the batteries. What are you using for those now? Pouch, cylindrical?
Early prototypes used A123, 1865 series cylindrical cells, but we've settled on pouch style, a large format,
right?
Prismatics from Dow Kokum.
Okay. And so let's take people on a quick around the patch flight here. All right, imaginatively. This aircraft, I assume, is probably, I haven't seen any other than the one illustration. I assume it's tricycle gear.
Correct.
Okay, so you're going to...
It's a pusher, of course.
Pardon?
It's a pusher, of course.
Of course. Yeah, it'd have to be. So you're going to you're going to wind the aircraft, you're going to get in the aircraft, you're going to turn it on. Are you going to be operating at that point on battery power, on the generator? What happens from takeoff to landing for a quick spin around the patch?
Well, during pre-flight and during run-up obviously you turn on the generator, warm it up, test it out, check your systems, and take off on batteries alone. Okay. The generator and the BMS is designed to kick the generator in at about 20% battery charge remaining.
Okay.
So take off batteries alone, take off, climb to cruise, 100% power for 2 minutes and 80% power another 4 minutes. And as a pilot, you understand how that works. Climb, get on the step, and you can toggle on or off or toggle up or down the generator, for more output or less output within a certain range, but also to when to turn it on and when to turn it off. So you can take off, climb to cruise on batteries only, and even have a short flight, less than an hour, on batteries only. And a fast airplane, that'll get you someplace, but just around the patch, you're fine with that. But this isn't a trainer. This isn't a around the patch airplane.
Right.
This isn't Sunday joyriding or taking a new student up for touch and goes practice type of an aircraft.
Okay, so I'm going to leave Portland and I'm going to fly to Santa Rosa for next year's Cafe Foundation meeting. All right, so that would, I would what, climb to 10,000 feet, whatever going to basically gives me clearance above the mountains, and I'm going to point the aircraft south. About how far am I going to fly before I'm going to kick the generator on?
Depending upon winds aloft, obviously, weather and wind conditions, 100, 200 miles. And the generator kicks in automatically, or you can toggle it on, at your convenience. Then the range extender generator, as it spools up, takes about 30 seconds. Recharges the batteries while in flight, not direct. It doesn't. It's a series hybrid. Doesn't. Right. It's not coupled directly to the traction motor.
Right.
But as a failover feature, the REX, range extender generator, can feed the traction motor directly in the event of failure of cells or a battery pack. All that notwithstanding, the range extender generator burns about 8.5 gallons per hour of automotive gasoline, just about any octane, supercharged at altitude. So with a 23-gallon fuel tank, you're keeping the battery level charged plus adding to it, and for just a little under 3 hours, you'll find yourself in Santa Rosa with enough battery charge remaining at time of destination having flown through the air at about 55 to 60% cruise power setting, you'll find yourself at your destination. Santa Rosa is actually a pretty good example. That's about a 600-mile run. To comply with the FAA 30-minute VFR, 45-minute IFR reserve, fuel requirement.
So that will get me there. I'm burning 8.5 gallons of fuel, 23 gallons. So yeah, so that would be about 3 hours, roughly 3 hours flying time plus the cushion. Well, by the way, I forgot to ask you, what's the size of the battery pack? How many kilowatts are you carrying?
A little over 60 kilowatts.
60? Okay. All right, great. Where are you going to be with respect to certification on this? I noticed that with Pipistrel, that's going to be classified, they're going to classify it as an experimental. There's going to be some owner assembly required. Is this kind of the approach you're going to be taking, similar approach, or are you going for full FAA certification?
I think it would be a big mistake to go for full FAA certification. So many big companies with a lot of resources behind them have tried to do that unsuccessfully. Atom Aircraft, for example, you may recall, is a beautiful airplane. Didn't quite make it. They tried to pursue certification. I mean, that's tens or sometimes hundreds of millions of dollars. Yeah. Epic Aircraft, a number of very light jet manufacturers have tried to do the same thing. We've chosen to, in the experimental category, for a lot of what I think are the right reasons. One, our manufacturing capacity isn't yet to the point where we could keep up with demand anyway. This is such a beautiful high-performance aircraft, and the purchase inquiries are so strong that we couldn't keep up if we were certified. Not at this point. But most importantly, it's a 2, 3, maybe more, sometimes 5-year exercise, and again, tens or hundreds of millions of dollars to achieve FAA certification. The experimental category allows us to, hence the term, experiment with new technologies with a lot more lateral flexibility and freedom. And the EAA and the EAA chapters, as Dick Van Grunsven and Van's Aircraft have proven, are very helpful, and so many owner-builders are adept at incorporating improvements in safety features and manufacturing processes. We can live in that world and keep up with demand and incorporate or invite in almost an open source format innovation and improvements and input from owner builders where you can't really do that in a certified environment. Does that make sense?
Yeah. Well, for people who may not be familiar with what experimental is, we're not talking about an aircraft that's unsafe. We're talking about an aircraft that hasn't gone through the complete, costly, expensive process of having the FAA basically write this, give it its complete and thorough endorsement. How for somebody who is familiar, private pilots and things who are familiar with experimental, I don't see this as really kind of an issue, but maybe the wife might be concerned, about, well, what are you doing spending, I think the figure I saw was about $500,000, something like that, for an experimental airplane, honey. So what do you tell her?
You tell her that back in the 1970s, when pioneers like Burt Rutan and others really developed the experimental aircraft category in the United States, it really was not a lot more than a set of blueprints in the mail that you would receive when you bought an experimental aircraft plan. It's just plans. And that's evolved thanks to guys like Burt Rutan, thanks to guys like Dick Van Grunsven of Vans and Lance Niebauer at Lance Air and Danny Mayer and the Swings at Velocity. That's evolved now to today, where an experimental aircraft owner-builder can go to the Builder Assistance Center and live and work there for sometimes a few days, sometimes a few weeks, depending upon your schedule and availability, and work side by side with a professional build team, an assembly team, and complete the aircraft to the FAA Part 23 standards, following and complying with the 51% owner-builder rule. So back in the day, you just got a set of blueprints in the mail, and during the 80s and even through the 90s, more often than not, when you bought an experimental aircraft, you got a crate full of parts,
Right. Yeah.
and in your driveway or at your hangar, and a set of instructions like you would from buying a piece of furniture at IKEA.
Right.
Those days are long gone.
Yeah.
Those days are long gone. It's my opinion, and it's prevalent and clear within the experimental aircraft industry that aircraft today, designed in the 21st century, using CAD design and modeling, using using modern and stiffer and stronger and lighter materials and material science, using parts fabrication and assembly processes, in many people's opinion, and I share that opinion, are better than most certified aircraft made today. And by better, I mean they're faster, they're lighter, they're they carry more payload, they're in many ways more innovative and higher performance in just about all categories.
Yeah, that's true.